Hey folks, welcome to lecture 3.2. We're making our way through chapter 3, ionic and covalent compounds, and we're going to be talking about ionic compounds that contain polyatomic ions. But first, I want to go back and do a couple of practice problems from the last section. So we've talked about ions and ionic compounds. I wanted to leave it off here with, we didn't get to this last time, so we'll think of it as a review this time. All right, so across the top, write the formula unit for the following ionic compounds. Formula unit means the elemental symbols and putting them in the right order, using subscripts to indicate how many, and putting them in the correct proportions to be neutral. Okay, the second part says write the name given the formula unit. All right, and then we'll get the last problem next. So go ahead and pause and answer these for yourself, and then come back. Okay, welcome back. So for sodium sulfide, we have Na2S, because we have Na plus and S2 minus. Again, looking at the periodic table, looking at the group, looking at the number of valence electrons, you can figure out the charges, and then we want to put them together into a neutral way. So Na2S and magnesium nitride would be Mg3 N2, where we have Mg2 plus and N3 minus. Copper 1 chloride would be CuCl. Right? Copper 1 means, it's a 1 plus 1. Cl is always minus 1. Copper 2 chloride would be CuCl2. Here the copper is a 2 plus and chloride is minus 1. So it's going to take 2 chlorides to balance out. Okay, and then we went the other way from the formula to the name. K2O is potassium oxide, the space in the middle. CaI2, calcium iodide. Okay, so notice the 2's don't show up anywhere in the names. It only shows up in the formula. If you say potassium oxide, we all know that it's a plus 1 and a minus 2, so it must be K2O. Next one, NaCl. We have sodium chloride. And ZNO, oxide. So zinc is, in fact, a transition metal, but it always takes a plus 2 charge, so we don't need Roman numerals. All right, the last question. Is the lead in PbO2 a lead 2 ion or a lead 4 ion? Explain how you arrived at your answer. Okay, so oxygen is always a minus 2, and the formula tells us that we have 2 of them, so we have a total of a minus 4 charge, and we have a lead, and there's only 1 of them, so the lead must be plus 4. Right, if lead was plus 2, and we had oxygen, then we would just have PbO. All right, let's look at polyatomic ions. The big picture is polyatomic ions are ions formed from molecules, right? So in the last section we had monatomic ions. Mon means one atom, or one, so one atom is an element that loses or gains electrons. A polyatomic ion, which is many atoms, is essentially a molecule that loses or gains electrons. So here are two examples, one of each. We have O2 minus, right? That's monatomic. It's simply an oxygen atom that gains 2 electrons, or that has, you could say, 2 more electrons than it has protons. And on the right is something called sulfate. It is SO4, right? So we see how there's an S and 4 oxygens. So it's SO4. But the whole molecule itself has 2 extra electrons distributed around the molecule, right? So the whole molecule has 2 more electrons than total protons. Now, SO4 is multiple atoms, right? It's an entire molecule, but you can think of it as X. You can think of oxygen as X, and they're equivalent. They're just X with a -2 charge, okay? And so think of this as just kind of a point charge, even though it contains polyatoms, right? Okay, so polyatomic ions here we can say also are derived from molecules, not atoms. They contain one or more covalent bonds. That's going to come up next section, but basically it means it's a molecule. It does, however, contain an equal number of protons and electrons, as we said. And each polyatomic ion has a unique name, formula, and charge. And unfortunately, there's really no rhyme or reason to some of these names and charges, but you don't have to memorize it. So that's the good news. You'll always have a table or something to look into it. So for example, NH4 plus, it's a nitrogen and 4 hydrogens covalently bonded to each other, but the whole thing has an imbalance of protons and electrons and results in a plus charge. So you could say NH4 plus, where the plus is the whole thing, not just a part of it, right? So that's called an ammonium ion. And another example would be CO3 with a -2 charge. So it's basically carbon and 3 oxygens, and the whole thing has a -2. It has 2 extra electrons relative to the number of protons. So looking at these two examples here, oxide and sulfate, what happens if we have a sodium ion that would make an ionic compound with it? Well, sodium is Na plus, we have an O2 minus, and if you remember the little trick, bring down the opposite charges, so we have Na2O1, or just simply Na2O. And it's neutral if we wanted to double check it, right? Each Na has a +1 charge, and there's 2 of them. And we have 1 oxygen with a -2 charge, and so 0. Following the exact same pattern, except with sulfate, where we just have a collection of atoms. Instead of O, it's SO4, but just think of it as X. Treat it the same. And so we'd get Na2SO4, right? So we get the 2 Na, and we get 1 SO4. So the 4 is still there. And it's just 1 sulfate ion. So we have 2 sodium, each +1, 1 sulfate, each -2 for neutral. Okay, what happens? We have aluminum ion with these. Well, aluminum plus 3, oxygen minus 2, gives us Al2O3, right? And then we can work it out. We could say we have 2 aluminum, each plus 3, and we have 3 oxygens, each minus 2, and so this is 0. And for sulfate, we know the pattern. We are going to want 2 aluminum, and we're going to want 3 sulfates. So what should we do here? Well, we can't just put a 3, because then now it looks like SO43, and that is very different, right? We want the whole SO4, and we want 3 of those. So the way we represent this is to put parentheses around it with a 3. So now this means we have an SO3 and an SO3 and an SO3, right? And three of those. And so the parentheses enclose a polyatomic ion when the subscript is needed. And I have that written here in the next slide. So in the formula unit, we need to use parentheses if we have a polyatomic ion when a subscript is needed. So more than one of them. And to show why, I have kind of a fun slide, kind of a silly slide. So why do we need the parentheses? What would it mean if we didn't put it? Right, so magnesium hydroxide is MgOH2, and we say it as MgOH2, but it's actually Mg and then polyatomic ion OH, 2 of those. So you have to be careful when we're speaking this. This is hydroxide, and it has a -1 charge. Magnesium has a 2+, so you can see why we would end up with the formula Mg parentheses OH parentheses 2. If we don't put the parentheses, like here, looks like MgO and then 2 H's, right? And that is actually quite different. And here's the example from before, Al2SO3 or SO43, and then without the parentheses, it looks like Al2SO43 oxygens. No, that would be a lot. So parentheses are necessary. There are a lot of polyatomic ions, and you do not have to memorize them. Here is a table. Most of them are anions, and we have 2 examples here that are cations with a positive charge. There's a little bit of reason and rhyme to the names, but we're not going to really spend a whole lot of time on it. Notice a lot of them end in ate or ite, right? So we have like nitrate and nitrite. They're both minus, so NO3 minus and NO2 minus. And then you have sulfate and sulfite, but it's SO4 2 minus, SO3 2 minus, so that there's a difference of oxygen there. But you can always refer to the table when you come across a polyatomic ion. So let's practice naming, just like before. So we're going to, given the name, write the formula unit. Given the formula, write the name. Okay, lithium hydroxide. So you can look at the table, find hydroxide. It's OH minus, and lithium is Li plus. So we have LiOH. By the way, you should pause and fill this out yourself. Okay, welcome back. Aluminum carbonate. So here's carbonate. CO3 with a 2 minus. I need more room. So we have Al3 plus and CO3, charge minus 2, put it together. And we get this, Al2, CO3, 3. Okay, next, sodium acetate. So acetate is CH3CO2 minus 1 charge. And it's sodium acetate. So sodium is Na plus, and so it's NaCH3CO2, which is kind of a long formula, but it's a 1-to-1 ratio, so we leave it as is. Next is lead 2 phosphate. So phosphate is PO4, the 3 minus, and it says lead 2, so we know it's a plus 2 charge. So we would end up with Pb3, PO4, 2. And right, you may be just quickly bringing down the charges to be the subscripts. All right, next, write the name given the formula. So the first one is NaOH. So OH, you might find it here as hydroxide. So NaOH is sodium hydroxide. AgNO3. Okay, NO3, you can find here is nitrate. And Ag is silver. And silver always takes a plus 1 charge. So we don't need anything else in the name. Next, NH4 2HPO4. So this one has 2 polyatomic ions, cation and anion. So NH4 is ammonium, and HPO4 is hydrogen phosphate. So we have NH4 2 HPO4 is ammonium, hydrogen phosphate. And the last one, Li2CO3. CO3 is carbonate, as we see here, minus 2. So Li2CO3 is lithium carbonate. That's actually all of this section. We're done with this lecture. So it's a short one. So use this extra time to go work on problems, work on your homework, work on learning curve. And we will continue next time with covalent compounds. See you then.